Hello everyone, you are watching Code with Shubhajit and let's get started with today's problem. So we have this sort colors, lead code 75, okay, and in that let's go through it once. So giving a brief that here we will be having an array which will be consisting of values either 0, 1 or 2, okay. So we have to actually sort this out. It looks very simple, right? It looks like normal sorting of an array problem. Okay, so if you see here, this is a nums array, then the having values 2, 0 and 1, right? So the output is 0, 0, 1, 1, 2, 2, which is the sorted form. But the twist here is we have to do it in the least amount of time, the optimized time, which is big O of n. Okay, so in single traversal, or we have to find a way where we can do it in linear traversal. Okay, let's go to our OneNote and I will start the things out from here. So let me take an example first. Okay, so let's say we have this array taking values to 1, 0, 0, 1, 0. Let's say it's like this. Okay, what is the first thing which is coming to my mind? The brute force approach. What's the first thing which is coming to my mind? It is, okay, let's sort this array out and the output will become 0, 0, 0, 1 and 1 and 2. Okay, this is the output array and that's all sorted, right? But the time complexity which it will be taking is big O of n log n. Okay, this is the average time complexity which optimized sorting algorithm takes. Okay, so in this case, we have to actually reduce the time complexity. Now, what all ways can you think of to optimize this? Sorting is done. Okay. One more thing which is coming to my mind, which can be a better approach apart from the brute force approach, which is I will run through this array once and I will be having counters because I know that either 0, 1 or 2, these three types of values are only the values which will be existing in the array, right? So I will have counter for 0, counter for 1 and counter for 2. In this case, counter for 0 will become 3, counter for 1 will become 2 and counter for 2 will become 1. Because how many 2's are there, how many 1's are there, how many 0's are there. Okay. Now, what we can do, we can run over this array again from 0th index till 0, 1, 2, 3, 4, 5th index. Okay. And what we will do, we will first initialize 3 zeros, then we will initialize two ones, and then uh, like only one time we will initialize two. So the final array will look something like this again. This is also an approach, but here if you can see that we are traversing the array twice, once for finding the count of zeros, ones and twos, and second time populating the values, which makes us 2 into n. Okay, this is a multiply, so big O of 2 into n. If we want to optimize this a little bit more, making it to big O of n, like a single traversal, how are we gonna achieve that? So if I think a little bit more, then you can see, let me take the array again. So the main focus here should be that we want to accumulate the zeros which we have towards the left, and we want to accumulate the twos which we have towards the right. And if we are able to do that, then the ones which are remaining, that will be in the middle only. Okay, because we are accumulating zeros to the left, twos to the right, so the ones will take its place on it, like, and the array will be sorted. So that should be our main focus. And let's say I take a pointer I at this initial position to maintain the pushing of zeros towards the left. I will take a pointer j for maintaining the pushing of twos towards the right. Okay, and I will also take a pointer k which will be traversing between I and j in order to check, okay, either we have encountered an 1, either we have encountered 2 or 0. Based on that, we will swap the values with either I, swap the values of this kth index either with value j. Okay, so that should be the approach which we'll be following. Now let's get into the solution part. Okay, let me just remove them for now. Yeah, that should be fine. So let's keep the j here. So initially the value of I will be 0 only. Okay, so this is the zeroth index. Let me cover that with 0, 1, 2, 3, 4, 5. Okay, and the k will also be having the value of 0 initially. I having value of 0 and k having the value of 0. Okay, so the logic goes like this. Uh, we will be running a while loop. Okay, let's not think about the situation in the while loop, but the while loop will be running till k and j matches. Okay, till k and j matches, because if k surpasses j, then that's it's not useful now, because we have passed everyone from I to j, and as we are initializing k and I both as 0, that's why I'm not taking the condition of I here, because while k will be running from I to j, definitely k will be either greater or equal to I. Okay, and this loop will stop when we the k and k has surpassed j. When they are equal, still the loop will run, because I will show you. So we'll be running this loop, and we will be checking that, okay, at index k, what's the value? If the value is 2, then we will be swapping this 2 with the jth index. Okay, we will swapping this out, and now we will make j minus minus. So at the index k, if we have, just I'm writing the pseudocode type of thing. If kth index, let's say this arr, the name of the array is arr. So if arr of k double is equals to 2, in that case what we will be doing, we will be actually swapping the kth index. I'm just writing it as kth index with the jth index, and I will make j minus minus, because now at the position j we will be having a 2, and we have, like, as mentioned, that yeah, we have succeeded in pushing like the values which are 2 to the right of the array. Now let's say if our arr of k is 0, you might guess it right, we have to swap the k with I, and I will make I plus plus. Why I plus plus? Because I will be moving here, because when we have secured this position for 0, I will be moving I towards the right, because I know that the left of I are always 0. Okay, I want to mention one more thing, that in this if case we will be also making k to k plus plus. Why is that? Because here we are definitely sure that whatever k value, like if let's say k is 2, okay, kth index is currently 2, I am definitely sure that towards the left of this, all these values should be either 0 or 1. They will not be 2 definitely, because if they will be 2, they are already swapped with j, right? Because in this condition that will be done. Okay, so that's why we will be doing k plus plus here, but we are not doing k plus plus in this situation, because it might happen that, okay, let's take this case only. It might happen that if there is a 2 here in spite of 0, then what will happen? We will swap this 2 with this 2. Again, again here in the kth position, 2 comes. If we have done k plus plus, then we have missed this 2. Then it's gone. The logic is gone. Okay. So we have to decrease the j, because we are definitely sure that this area is covered by 2. But here, the work of k is to push 2's to the right, zeros to the left. But here, the k's value can't be incremented, because here a 2 occurs again. So in that case, I will be swapping this 2 with this, because now the j is here. I hope you have understood this approach, and I will actually like give you a flow over the whole algorithm for this array, and then we can code out the solution. That should be definitely fine. I will also index them out: 0, 1, 2, 3, 4, and 5, and then we can have our k pointers. This is the k, okay, this is the I, and this is the j we have, right? So I will go with the values of k. Okay, so let's write it here. If k is 0, okay, if k is 0, in that case, what my algorithm says? My algorithm says that I will check that if k is equals to 2, if the index k, the value of the index k, is it equals to 2? Yes. So I will swap it with j. If I swap it with j, you can see 2 will replace here, but 2 will go here, so no change actually. But what will happen? J will become j minus minus. So now j will not be pointing here, j will be pointing this location. Fine and good. Okay, now k is here only because see, we have 2 here again. So again k will check. Okay, is the value 2 at the kth index? Yes, it's 2. So now it will swap it with 1. Okay, so now k is 0 only, and again it will do that thing. So here 2 will become, here 1 will come. Okay, and again j minus minus will happen. Okay, now let me write the I values as well. J value here is 5, j value here is 4. After j minus minus it became 4, after j minus minus it became 3. Okay, let me track the values of I, j and k. Okay, now going fine. Okay, again I will check that. Okay, is k 2? No. Is k 0? ARR k is 0. This is the ARR. ARR k is 0? No. But ARR k is 1. I have missed this. Okay. So whenever the value is 1, I don't have to do anything, right? Because the ones will be automatically adjusted in between, because we are pushing zeros to the left, twos to the right. Okay. So whenever this happens, so I will just write it out. ARR k, whenever it happens to be 1, I will make k plus plus. Okay. Nothing much. So here again k was 0. Okay, but it saw that okay, the value is 1, so k's value became 1. Okay, so now k shifted from here to here. It saw again, okay, the value of the value at kth index, that is 1th index, is 1 only. So I will not write it again, so it will be changing it to 2. Now we are at k is equals to 2. Okay, fine. Now we found a 0. Now inside this if condition it will go, and what will happen? It will swap the k with I, it will make I plus plus and k plus plus. Okay, so it will swap this with this. So here 0 will come, here 1 will come. Okay, and now I am making the value of I to I plus plus, because I am pretty sure that left of I values are 0 only. Okay, definitely fine. I am going good. Okay. So now after doing this, I will also increment the k. Now k's value is 3. Okay, fine. We encountered 0 again. So we'll do the same process. What we will do? We will actually, so k's value is 3 here, and what we will be doing? We will be swapping it with the present I, which is 1, and I will be making I plus plus. So this will become 0, this will become 1, and I will be becoming I plus plus. So I became 2 now, j is still at 3. Okay, I have missed doing this. So currently j is here. Yes, j is here because after assigning it to 2, j has decremented right here. J is 3 now. Okay, so you can see we are at k is equals to j position now. Okay, and still the loop will run because while k is less than equals to j. After this, what will happen? I encounter a 1 at k. So k plus plus. When I do k plus plus, k will become 4. We have the j as 3. We have the I as 2. Okay. In that case, our while loop will break because now k is greater than j. And in that case, if you see the resulting array what we have, hey, sorry, the resulting array what we have is sorted 0, 0, 1, 1, and 2, 2. Okay. Okay, I hope you have understood that in between I have taken this as 2 to explain you better, and that's why there are two twos coming. If we have taken this solution, then the output will be a bit different, 3 zeros, 2 ones, and then 1 2. But as I have taken 2 here to explain you that why case position should not increment, that's why it's like that output. Okay, I hope you have understood the approach. Now we will code this solution out. Okay, so we have to initialize the I, j, and k values first. So let me initialize that. Int I is equals to 0, j is equals to nums dot length minus 1. Okay, and k is equals to 0 again, because I and k values will be same that the initial value. And then I will run a loop which will say while j, yeah, while k is less than equals to j. In that case, what I will do, I will check that, okay, is my nums. So here we have they have taken nums. You can change it to ARR because that's what we have taken in our example. So if ARR of k is double is equals to 2, in that case, what we will be doing? In that case, we will just think and you can comment this out. So whenever it is 2, what I will do is I will swap the ARR uh, k and j pointer. I will make j minus minus. So what I have done, this swap method I will be creating. This is basically for ARR, I will be swapping the k and j values. Okay, this is a method which I will create. Don't worry for that. I will create it later. After this, let's say if ARR of k double is equals to 0, what we'll do in that case, we will actually swap ARR's kth index and ith index, and I will make I plus plus as well as k plus plus. Okay, when that is done, what I will do, I will also check else condition. It means that ARR k value is 1 because 2 and 0 we have checked, and in that case I will make k plus plus because that's totally fine for me because it's a neutral one value. I don't have to push it to anywhere, it will just take its place on its own. Okay, so that is done. Okay, the whole loop ends here, and once that is done, we will be having inside ARR the value, and you can see here that we are not returning anything. Why? Because it will detect the change in ARR, and it will uh, like compare the test cases along with that. Like, we don't have to create a new array, we have to make changes in this ARR only, and this is called an in-place solution, where we don't create a new array, we actually solve that in the present area only. Okay, so yeah, that is done. I just need to create the swap function which I'm using. So what I will do, uh, public void swap. So int arr int x int y. Okay, because the values might get confused for you because they are I, J, and K. And what we will do, we will just swap them. If you don't know the function of swap, you can write it below in the comments. Let's check. So we have a temp which will be ARR of x. We have ARR of x is equals to ARR of y, and we have ARR of y as temp. This is the standard swap which everyone knows, almost everyone knows. Okay, so let me run through the solution and see if I have got any errors or not. Okay, so both the test cases passed. Now the challenge for you is, whatever I have coded it out, you try to code it on your own and see if after submitting all the test cases pass or not. Okay, I hope you have understood this, and if you like this, do like this. If you don't like this, just like this, and just comment it out, share it to your friends, and keep learning, guys. Thank you.